The semantic web. The semantic web is a project that intends to create an universal medium for information exchange by putting documents with a computer processable meaning on the World Wide Web, a web talking to machines. The goal of the semantic web is to be a web talking to machines, in which machines can provide a better help to provide because they can take advantage of the content of the web. The information on the web should thus be expressed in a meaningful way accessible to computers. This definition is easily related to what already exists on the web: wrappers for extracting data from regularly structured pages, natural language analysis for extracting web page contacting, indexing schemas, syndication facilities for broadcasting identified web resources. Much of this is painful and fragile. The semantic web should make it smart and robust. The semantic web can also be thought of as infrastructure for supplying the web with formalized knowledge in addition to its actual informal content. No consensus exists on how far the formalization should go. It ranges from metadata schemas to full-fledged logical representation languages. This exists only for practical applications and is currently limited to a small subpart of the web. On the challenges of the current semantic web development is the design of the framework in which all these understandings can collaborate, because the full benefit of the semantic web can only be attained when computers relate resources from various sources. The Semantic Web initiative of the World Wide Web Consortium has been active for the last few years and has attracted interest of skepticism in equal measure. The initiative was inspired by the vision of the founder, Tim Berners-Lee, of the more flexible, integrated, automatic and self-adapting web, providing a richer and more interactive experience for users. The W3C has developed a set of standards and tools to support this vision, and after several years of research and development, these are now usable and could make a real impact. The semantic web is inspired by a vision of the current web which has been in the background since its inception, and which is influenced by earlier work dating back to Vannevar Bush's ideas of the Mamex machine in the 1940s. Tim Berners-Lee originally envisioned the WWW as including richer descriptions of documents and links between them. However, in the effort to provide a simple, usable and robust working system which could be used by everyone out of the box, these ideas were put to one side, and the simpler, more human-mediated web which we know today resulted. The bigger vision found expression in the article written by Tim Berners-Lee, Jim Handler, and Ora Razila in Scientific American in May 2001. In this article, they provide a compelling vision of the world there instead of people laboriously traveling through information on the web and negotiating with each other to carry out routine tasks such as scheduling appointments, finding documents, and locating services. The web itself can do the hard work for them. This can be done by providing sufficient context about resources on the web and also providing the tools to use the context so that machines can find the right things and make decisions. In the words of the article, the semantic web will bring structure to the meaningful content of web pages, creating an environment where software agents roaming from page to page can readily carry out sophisticated tasks for users. This is an ambiguous long-term aim, nothing less than imbuing the web itself by meaning, that is, providing meaningful ways to describe the resources available on the web and, perhaps more importantly, why there are links connecting them together. Thus the notion arises of semantics being part of the web, capturing the reason things are there. Once the web has a mechanism for defining semantics about resources and links, then the possibility arises for automatic processing of the web by software agents, rather than mediation by people. In the same article, the semantic web is defined as 2JISC technology and standards. Watch semantic web technologies.
The technologies. Another common use of the term semantic web is to identify a set of technologies, tools, and standards which form the basic building blocks of a system that could support the vision of a web imbued with meaning. The semantic web has been developing a layered architecture, which is often represented using a diagram first proposed by Tim Berners-Lee, with many variations since. This figure gives a typical representation of this diagram. While necessarily a simplification which has to be used with some caution, it nevertheless gives a reasonable conceptualization of the various components of the semantic web. We describe briefly these layers. Unicode and URI. Unicode, the standard for computer character representation, and URIs, the standard for identifying and locating resources, provide a baseline for representing characters used in most of the languages in the world and for identifying resources. XML. XML and its related standards, such as namespaces and schemas, form a common means for structuring data on the web but without communicating the meaning of the data. These are well established within the web already. Resource Description Framework (RDF) is the first layer of the semantic web. RDF is a simple metadata representation framework using URIs to identify web-based resources and a graph model for describing relationships between resources. Several syntactic representations are available, including a standard XML format. RDF schema, a simple type modeling language for describing classes of resources and properties between them in the basic RDF model. It provides a simple reasoning framework for inferring types of resources. Ontologies, a richer language for providing more complex constraints on the types of resources and their properties. Logic and proof, an automatic reasoning system provided on top of the ontology structure to make new inferences. Thus, using such a system, a software agent can make deductions as to whether a particular resource satisfies its requirements. Trust, the final layer of the stack addresses issues of trust that semantic web can support. This component has not progressed far beyond a vision of allowing people to ask questions of the trustworthiness of the information on the web in order to provide an assurance of its quality. What is metadata? The term meta derives from the Greek word denoting a nature of a higher order or more fundamental kind. What metadata actually means is essential data about other data, also known as meta-language. Metadata can be used in any sort of media to describe the contents of the information. It consists of descriptive information about a particular data set, object, or resources, including how it is formatted, and when and by whom it was collected. Although metadata most commonly refers to web resources, it can also be about either physical or electronic resources. Using metadata, it is responsible to create customized tags for markup languages such as XML and HTML. Metadata schemes are recognized way of describing and formatting metadata. Each metadata schema will usually have a limited number of elements, an element name and a meaning for each element. Some of the most popular metadata schemas are doubling co, double ACR2, GILS, EAD, IMS and AGLS.